It is the 7th of March, 2019. We're in already recording video. It's at 2 minutes and 8 seconds. And we are looking to cut traces on the board for the remote control, or the controller board, I guess, of the remote control truck. I did some research, and it looks like an X-Acto knife is the way to do this. And now I've got to figure out where exactly my X-Acto knife is. I think I'm going to shut the video off because I'm not taking any video of anything right now. And then we'll shut it off. And I will leave the audio going and try and figure out where the X-Acto knife is. We were not successful in locating an X-Acto knife. I have an Olfa knife, and I have a utility knife. So we'll see if either of those is appropriate for cutting these traces. So according to the internet, what I've got to do is I've got to slice out a teeny bit of the trace in between where I've soldered one connection and where I've soldered the other connection. So this trace here and this trace here, so these, the one that kind of goes through the middle of the four, and then the one that goes a little bit further away than that, are the two traces that I am going to be cutting. That is for this little guy does the steering, that little driver chip. So we're going to place the knife on the trace, just kind of work it back and forth a little bit. Now, when I was scratching at these things, I know, oh, that's not sharp enough. I'm going to have to break off the blade and get to a new end sharp version. Lock that in place. So we'll just put this down and wiggle. Doesn't help. I can't exactly see what I'm doing here. And I'm going to resist the urge to draw the blade toward myself in a sawing motion, because, as was vividly described and illustrated by some YouTube videos, that can easily end in, well, damaging yourself, because you can cut yourself when the knife slips, but damaging your project. We're just going to try and peel the copper. To show that there is a teeny bit missing between. See, this isn't doing me a whole heck of a lot of good here. Now, one of the theories for what went wrong with the first of my Arduino, or my Minions is that I used my meter, which just happens to have a 9-volt battery in it, to check some connections back and forth after things were soldered. And because the 9 volts is quite a bit higher than the maximum of 6 volts that these electronics can deal with, I suspect that I blew the crap out of my out of at least the drivers, but more likely the MCU, or the actual brains of the system. Now these are going to be a little bit more interesting. The section that I want to remove, and I'll try and illustrate this here. There's 2 traces. I'm soldered on here and here, so I'm going to be taking out a chunk in there. I'm soldered on here and there. I need a chunk out of the middle of those 2. So the wires are very close together, and it's not going to be very easy to take a chunk out of them. And when I'm cutting this trace here, which is, if you're looking at the second one, this trace is one I want to keep, this trace is one I don't want to keep. So they are quite close together. And I guess if I accidentally cut through, then I will be looking up on the internet how to fix traces and solder teensy little wires over top to bridge gaps, because there really isn't a whole lot of wiggle room in here. Now it is a single-sided board, which helps. All of everything that's got to be seen is visible. Okay, I can see copper. What I'm doing is taking about 2 millimeters out of it, and I'm not really going to be able to tell that it worked until I turn it on. Because like I said, the act of measuring whether it was still connected seems to have caused failure, or may have caused failure, in my other board, which is not very nice. I don't have a whole lot of room in there to wiggle. An X-Acto knife would be a little easier to deal with. Certainly wouldn't dig such a large gouge. But, well, that appears to be in the right place. That particular location happens to have a mounting hole beside it, so I was able to use the location of the hole as a target for the blade of the knife. I'm quite sure that I've made it through the trace. There's just not very much gap there. I would like there to be more gap. I would very much like there to be more gap. Let's see. Start in this direction. I might mention that this is a very crude method. Okay, I would say that that is a big enough gap. And we are going to try get some pictures of that. What's my time here? Oh, I got a little bit of time left. So, let's see if I can take the video camera. Stop it. Okay, let's take a peek. That's actually probably not bad. So then we're going to flip this over the other way. So I've got 4 traces that I cut, and we will find out when I load some new software whether it worked. So we'll shut this guy off. And we are at 13 minutes and 20 seconds, and we shut off the audio. Okay, it is the 7th of March, 2019. We are changing some code for LRW Minion Remote. And I have a problem here somewhere. I don't see it. But and apparently I just tunnel, run forward, remote. There we go. Okay, we are 26 minutes, so we've got some video that no one's going to want to watch because there's nothing happening. Okay, let's Control U. Expected open bracket before digital read. Expected declaration before curly. Unqualified something or other before if. So there's a bunch of errors. Expected bracket before digital read. Okay. So digital read is a function, and it has to have brackets around it to evaluate. to a false or a true. Okay, let's try that again. We have audio on, compiling the sketch. Okay. How many errors do we have now? If loop counter is greater than 10. Expected unqualified ID before if. Did I miss a semicolon somewhere? Digital write, digital write, digital write. I've got ifs and digital writes. So I'm going to put a semicolon in, even though I think that's silly. See if it's happy. Oh. Well, it's not where it's complaining about. It's complaining about here. Well, that doesn't make a whole lot of sense to me. I'm going to put a semicolon and see what it gives me if there's an error. Expected unqualified ID. That don't make a whole lot of sense to me. If loop counter is greater than 10, it's unhappy with. It wanted something. Wanted a semicolon. So, oh, I have an extra. That's what it is. I had an extra set of curly brackets in there. So that's why I was complaining about the if loop counter, because it should have been the avoid. Okay. Happy. Okay. I'm going to turn this on. I'm going to turn this on. Control Shift. What is it? Control Shift M for serial monitor. Okay, we got a lot of zeros happening. Okay. I think this is bad. So what I'm going to go do, shut this remote off and close this and go back to run all four. And then I'll download that one. Control U. Okay. Control-Shift-M. Control-Shift-M. Okay, so I'm going to hit Enter. I feel like an idiot. And the reason that I feel like an idiot is because I purposely unplugged the board, the connectors on the board, so that nothing got destroyed while I was cutting traces. So nothing did get destroyed when I cut traces. However, in order for anything to move, you sort of have to plug the connectors back in. So, now that I'm finished feeling silly, I'm not sure why that doesn't want to go on. I probably bent stuff. Okay, so then we take this, set it back on top so that the LEDs are visible. Turn the remote back on. Okay. Uh-oh. So we are blinking 3 times. We have the outputs on. Okay. So it turns to the right like it should. And we're going to show the 4 blinking. Okay. Turns to the left. Okay, and with 5 it doesn't do anything. Okay, so we're going to go Control, we're going to kill that. Go Control U to start again. It is compiling. Uploading, done uploading, Control-Shift-M, gives me 0. So we are going to hit Enter, and now it's 1. That does not seem to work. Hit Enter again, we'll get 2. That does not seem to work. We hit 3. So we have steering, 4. So okay, We're going to hit enter again, so it stopped doing that. And there's a possibility that I have broken this thing again. So I'm going to load up my remote, LRW Minion remote, and I'm going to download it, and I'm going to see whether my remote does anything. So we're going to go Control U. Compiling the sketch. Uploading. Done. Control Shift M. And I got a lot of zeros. Okay. Now I'm going to hit forward. I got nothing. Reverse. I got nothing. Steer. Works to the right and works to the left. So at the very least, it's consistent with what I was expecting, since this other thing didn't work. So now I'm going to go into my ifs, and I'm going to say I'm going to reactivate my command by so command equals 1 if radio right, and command equals 0 if not radio right. And command plus equals 2 if we have radio left, and plus equals 4 for forward, and plus equals 8 and then I should and then we will print command. So Control U, compiling the sketch. Control Shift M after it finishes loading. Okay, so I get nothing for forward, nothing for reverse. I have my little light on, so I get a 1 and I get a 2. forward and reverse do not appear to be getting to the Arduino. Well, that's very interesting. They used to come. And it is even more interesting that my time-based one, where I said just go forward and all the rest are inputs. Let's go take a look at that one. Read radio. Let's go ahead and load that one up. So the read radio has all of the outputs defined as inputs. So the outputs and the inputs do not fight. So we will download that one. Actually, we'll compile it and then download it. It is now 9:15. I should be kind of wrapping this up here pretty quick. Loading. Done. Excuse me. Okay, I have 0. I push forward. I get nothing. I push back. I get nothing. I hit right. I get nothing. I hit left. I get nothing. Oh, I guess it would help if I turn the remote on. Okay, one more time. Forward, I've got a red light, but nothing. Reverse, I got a red light, nothing. Right, I've got 1s. Left, I've got 2s. So I killed something. Not sure what exactly I killed, but I killed something. So, I think what I'm going to have to do is disconnect. So I'm going to close this, close Arduino, disconnect the Arduino, pull it out of the board so it is no longer connected to the board. Actually, close up the laptop, move it over, move it away so that I don't break anything. Shut off this thing. So now it is indeed off. So it is not very likely that I messed up anything there. Okay, so those two and those two work. These guys that don't. Oh, that one looks like it's touching. It's possible that I had something shorted. If I did, it's probably dead though. So how will I take 3.3 volts and jumper it over to the chip. What I'm doing is I'm trying to get 3.3 volts to here, this pin, or this pin to no, this pin, that pin, or this pin. Well, let's go take a look at the laptop, find out which pin is which. This is not in Arduino. This should be in Little Red Wagon. Okay, so looking at the schematic, I've got the 14-pin chip on the top of the board. I am looking for 3.3 volts on pin 2 is forward, and pin 3 is reverse. Or actually, reverse is 2 and 6, forward is 3 and 7. So pin 2, look at this side, here is the notch, so this is pin 1, pin 2 is the second from this edge of the board, which should be, move these guys out of the way a little bit, this guy right there. So I just don't know how to get 3.3 volts to him. I don't have any 3.3 volts available on the header. The 3.3 volts was coming from the Arduino. So now without the Arduino, I don't have 3.3 volts available. I have 3.3 volts available on pin 1. So if I short pin 1 and pin 2 together, the truck should go reverse. So if I take a very small resistor, put those things together like this, turn this on, and is this thing, oh, we're down to 2 seconds, okay. Okay, we are recording again. That was very convenient. We had stopped recording for very little time. So, pin 1 and pin 2, I'm actually going to touch from the top side here, because I can actually see pin 1 and pin 2 much easier. So, we're going to connect them. And that doesn't do anything. Well, isn't that interesting? Let's take the voltmeter, which is not on continuity, but is actually measuring voltage. 0 volts is where? 0 volts on the 14-pin chip. 10, 11. Well, I've got a wire soldered to negative. I can just put a wire over here. Now my red wire is starting to get a little frayed. It's getting bent too often. I think I have a gator. Let's see. Can I carefully put the gator on? I think so. That gives me my negative. And I'm expecting pin 3 to be positive. And it is. Okay. And I don't know how to hold this little resistor in place while still measuring voltage. But I'm going to try. I'm wondering if down to 4.7 volts, maybe the battery just needs to be changed. That is really quite okay. So the resistor's too big, it doesn't let enough current through. So if I give 3.2 volts to the correct place on the driver, it does what it's supposed to do, which I believe is reverse. Come on, girl. Yeah, reverse on pin 2. So, I lost my connection to I guess because I'm not getting the input signal. I shouldn't be expecting the output signal, but I did try the output signal directly. So I'm not sure what exactly is going on. Maybe I killed both connectors. So the 3.2 volt signal on my microprocessor is forward is 10, reverse is 10 and forward is 11. 10 and 11. Any chance I'm going to get to that? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I need my little piece of wire, wherever I put that little piece of wire, to jam my throttle. Of course I don't have it here. Well, I don't really see anywhere that I could have put it. Mind you, it's a small coil of wire, so I wouldn't be able to see it all that well. I don't appear to have put it down beside anything. Oh, yep, I did. Okay. So we are going to give ourselves a continuous reverse. Signal. And I am going to check pin 10. 9, 10. Actually, that was what I used the little all for, because it's really tight in there. Okay, I am actually getting a signal. Alright, so the signal is good. I go back and give myself a forward. Is it still visible? Yeah, kind of. So that's pin 11, which is this guy. He also is giving me the correct value, 3.3 volts. Okay. Now I got to figure out which pin that's connected to, or which wire that's connected to, and which one is it connected to? D4, D5. I guess I'm going to have to open up the Arduino code. See which pin that is. See if the wire is still connected. So run forward, which is where we are now, is pin 6. We start the pins at pin 4, I think. Yep. We got 4, 5, 6. Third one. And that's the third one from this end on this side, so we're going to put it in there. And the value that we have now is 0. Okay. I am going to go for pin 4, which is the first one. I'm going to turn. Okay. Steer right is supposed to be pin 4. The probe fell off of the meter. Okay, so steer right. Not give me anything there. Okay, so maybe it's this side. I'm just horribly confused. Steering was working. So I've got nothing on that pin. Okay, do I still have any wires on this thing? Okay. Okay, so I have a signal. Now I have a signal on pin 3. Okay. I have a signal on pin 3. That's excellent. Unexpected, but excellent. And it goes away when I let go. Now I'm going to go to, that's not pin 3, that's 4, 5, 6. 7 should be the other direction. And we get that. Okay. 4 should be that one. So the one that worked. Okay, so do I just have it pushed in too far? Nope. I'm giving myself a headache. Okay, so I'm just walking through the signals. I think this one should be on when I do that, and it is. This one should be on when I do like that, and it is. So now I have the forward and reverse signals apparently working, and the steering signals not working. Although when I tried using it, it was the other way around. So steer right and steer left worked, forward and reverse didn't. So steer radio right. Oh. Okay. Let's start again. I really need to make my labeling better. Is this still visible? Yeah. So, I was talking about the outputs, not the inputs. So, 4, 5, 6, 7 are the outputs. 8 is an input. Pin number 8 is forward. So we're going to hit forward, and I do not get a signal. Okay, reverse, I don't get a signal. So that is pin, if we start at 4, 5, 6, 7, that's 8. Pin 9, forward is nothing, reverse is nothing, left is nothing, right is nothing. Okay, the next one after that should be right. Actually left, sorry. So left is pin 10, and left does work correctly. And then pin 11 should be right. And right works correctly. So the radio inputs four, 5, 6, 7, so 8. So this signal is coming from right there. That's reverse, that's forward. And these wires are not connected to those traces anymore. So the scratching around that I did apparently did more damage than it was supposed to. And those are no longer connected. So I may have to move these little wires up onto the pins, which is going to be painful for me. I have verified that I didn't blow up the driver card or the driver chip. So actually, I'm not all that worried about having the correct signals. I think what I'm going to do, I'm going to disconnect this, shut it off, make sure it's shut off. Yep. And then I'm going to call it quits for the night because I'm starting to make silly mistakes. Shut this off. And I will try tomorrow, or whenever I get to it. I proved that I could, with the Arduino code, I could turn left and right. I will change the code so that left and right actually run it forward and back. If that works, then I won't worry too much about the radio remote inputs. They'd be nice to have, but this is pretty precarious right now. I think I'll settle for having the motors controllable rather than having the inputs to the Arduino correct. So I just shut off the audio, or shut off the camera. We're at 45 minutes and we're shutting off.